This is R.D. Sharma solution, class 12th, chapter 17. We are taking MCQ, increasing and decreasing functions, multiple choice questions. The interval of increase of the function fx is equal to x minus e raised x plus 10 pi 2 pi by 7 is. Now in this interval, we have to find out the increment, the interval in which it is increasing. So f dash x has to be greater than 0. That is the only thing which we need to prove. And the f dash x, which is the differentiation, x is 1, e raised x is e raised x. And this is a constant. This is for just to confuse the candidate, student, that is tan 2 pi by 7. That is just a constant. And when we differentiate it, it is going to be 0. So we have dash x equals to 1 minus e raised x greater than 0. That means 1 minus ex is greater than 0, 1 is greater than e raised x. Or you can say e raised x is less than 1. Now the next thing, what comes here is, e is what? You know about e. E is a constant value, 2.1744 something. Now constant value, if you put any value x over it, that is, it has to come lower than 1. I am saying 2.17 is there. Now if you put any positive power, 1, 2, 90, 90 lakh or whichever, it will be greater than 1. But if you put 2.17 to the power, anything which makes it lower than 1. So this is possible when we have less than 0. That is, if you put negative 1 by 2.174, that is going to give you a value which is less than 1. So this minus 1, this is basically x should be less than 0. In number line, if I want to show it, anything which is less than 0, you will go up to negative infinity. So negative infinity and 0, that is the interval they are asking, is from negative infinity to 0. X belongs to negative infinity to 0. What is the option? This is the second option we are talking about. Now let us see how you are going to write it, because writing is very important. It's a very straightforward question. The function fx is equal to cot inverse x plus x increases in the interval. In which interval it is increasing? First thing is f dash x greater than 0. That is what we do normally. If it is decreasing, we just make it as less than 0. The differentiation is cot inverse x is minus 1 by 1 plus x square. That is the differentiation. X is 1. This is 1. Now let us take the LCM to make it more simplified. Multiply cross, write it, and multiply the denominators and just write it in the denominator. 1 gets cancelled. You have x square by 1 plus x square. This I hope you'll be able to do by yourself also. Now this has to be greater than or equal to 0 because it is increasing. Now you tell me, x square. Just use a simple logic. X square will always be positive. Even if you add 1 with it or any number which is positive, it is going to be positive only. That means this whole value, numerator, denominator involved or collectively said, this will always be greater than or equal to 0. So if you put any value negative or positive, you are going to get always positive. It is always greater than or equal to 0. Because negative value will be negative infinity to 0. You can put any value, but when it is squared, it will always be positive, because anything even powered to any x value or y value, it will always be a positive value, right? So this is asking about the function. This is in the interval. Which interval it is increasing? In which interval? So you can say x belongs to, that is, you are going from negative infinity to infinity. I'm saying it will always be positive, but negative infinity to infinity the answer. So this is the simple explanation. It's very simple if you show it on the number line. The function fx equals to x raised x decreases on the interval. Now we have to show the decrement. Well, first thing first come here is the differentiation, and I hope you are well aware of the differentiation we have done in the actual differentiation when we did it. So x raised x can be done by using the log. That is, if I write fx equals to x raised x, then the differentiation will be what? You have to take log on both the sides, then the differentiation will start. So when you take log fx, this is log fx, and you have log x raised x. So this x is going to come forward. X will come in front of log, and internal x will remain like that. So x, the base is not given. We have taken the base as e. Let us differentiate it now, because differentiation of log anything will be 1 by that thing. That is, when we do a log fx differentiation, it will be 1 by fx. I'm differentiating both the sides. So it is going to be 1 by fx. Now the differentiation of fx is going to be f dash x. Log, whatever it is there, it will be 1 by that thing, and then differentiation of that thing. How about x log x? X log x is 1 by x, plus this is log x. Differentiation of x is going to be 1. This gets cancelled. You have 1 plus log x, and on the left you have f dash x, and this fx goes on the right side. I've just cross multiplied. You already know it. X raised x we have started. Fx you can just replace it by x raised x. into 1 plus log x. This is your differentiation. Now this has to decrease. Decrease means this whole content should be less than, or this whole expression should be less than 0. That is x raised x 1 plus log x less than 0. Now there are two terms here. First is, when you have log, there can be nothing negative inside. X should always be positive because log is defined for the positive values. X should be greater than 0. Now when x is greater than 0, anything of the same power, if 2 is, I'll just give an example. If 2 is greater than 0, 2 raised 2 will also be greater than 0. That is 4 will be greater than 0. That is what? X is any number, and any number raised to that number only is going to be greater than 0 when that number is greater than 0. So the first term is greater than 0, that is positive. Now in order to make this both term multiplied less than 0, the second term has to be negative. That is the whole logic. That is 1 plus log x should be negative. It should be less than 0. Let us take 1 on the right hand side. Log x should be less than negative 1. That is e power, the power is e, that is the base is e. When we say log base a b c is equal to, it's simply a raised power c is b. So e raised a negative 1, this is x will remain here and this will go on the right. E raised minus 1, x should be less than e raised minus 1. Same logic of log I have just written like this. Just forget about less than sign, keep it equal and then just replace it by less than. Then you will be able to write it properly. So x is less than 1 by e. E is a constant value, 2.714 something. So it will be positive only. 1 divided by 2.714 will be point something, 0 point something. If you even put e raised minus 1, if e is greater than 1, e is greater than 1 means 2.714 is already greater than 1. Okay. So x should be less than e raised minus 1. This I started. And I told you x is less than 1 by e because e raised minus 1 is 1 by e. Two things we found. X should be less than 1 by e, and second thing we got from here is x should be greater than 0. I hope you got the idea. The first term, it has to be positive, greater than 0. X has to be greater than 0. The second one is x should be less than 1 by e. Now combine these both and just join them. That is, x should be greater than 0 and this is 1 by e, x should be less than 1 by e. So this is the common point, this is the intersection point, and that is going to give you the interval. So x should be between 0 and 1 by e. Then you will say, okay, this is going to decrease. The third option is the correct option here. Now let us find out how we are going to actually do it. This is the different steps which you are going to follow, and I will encourage you to write or make the diagram that will effectively prove your point to the examiner. The function fx is equal to 2 log x minus 2 minus x square plus 4x plus 1 increases on the interval. First thing is we have to differentiate it, and increases in the interval means it has to be greater than 0. Whenever we have log, sine, cos, the domain you have to find out by yourself. I am saying whenever you have log and you have any term inside, say x, this x should be greater than 0. It should not be equal to 0, it should be greater than 0. When you have this x minus 2 inside, the same logic goes for that thing also. That is, x minus 2 should be greater than 0. That is the logic we know about log. So x should be greater than 2. One thing is x has to be greater than 2. Below 2, this whole expression becomes invalid, or you are not able to solve it right now. The logical value is greater than 2. So domain becomes 2 to infinite, because x cannot be less than 2. 2 to infinite, it can be any value. Now coming to 2 log x minus 2 minus x square plus 4x plus 1. So f dash x is, let us differentiate 2 log x is 1 by x minus 2. Differentiation of x minus 2 is going to be 1. And minus 2x, 4x is 4 plus 1 is 0. Now we are going to solve it, and I hope you will be able to solve this properly, because just take the LCM and there will be an expression. And let me write the final version, because I hope you will be able to do it. It's very straightforward. So final version is going to be minus 2 x square minus 4x plus 3 divided by x minus 2. That is going to come. Okay, it is increasing, so it has to be greater than 0. F dash x or differentiation should be greater than 0. Now tell me, minus 2, it is less than 0, no problem at all. X minus 2, I already told you that it has to be greater than 0. So x minus 2 is greater than 0. So that 3 terms on the left, minus 2 is less than 0, x minus 2 is greater than 0. So this cannot be negative. This is negative. I am saying x minus 2 is positive. X square minus 4x plus 3, because minus and x minus 2 is again positive and minus 2 is negative. This is positive. Okay, I've just changed it because I wrote negative first. So the below x minus 2 is greater than 0, it is positive. Minus 2 is negative. So what should x square minus 4x plus 3 sign should be? I am saying we have 3 terms, a, b, c. A is negative, C is positive. What should be B, so that the whole multiplication and division becomes greater than 0. It has to be negative because negative is positive. Okay, so we need a negative value. That's what discussion is all about. So we have x square minus 4x plus 3 should be less than 0. It should be negative. Next step comes is we have the x square minus 4x plus 3 and it has to be less than 0. Let us now take the roots. X square minus x minus 3x plus 3 equals to 0. Now we'll not make it as 0. We'll just find out the factors. X into x minus 3 you can take common x minus 1. Factor will be x minus 1 into x minus 3. That is, this is going to be 0 at x equals to 1. This is going to be 0 at x equals to 3. So we have, now let us use the number line. It will be better to have the number line. To get it less than 0, I already told you in the beginning of the chapter, I explained you properly that when factor multiplied is less than 0 or factor multiplied is greater than 0, what is the final result? So we can get the final result, that is 2 to infinite. The first one came, I told you already. That was the domain, log x minus 2, I told you. And here the answer is coming between 1 and 3. But domain is saying that it has to be greater than 2. So what is the common point here? The common point is between 2 and 3. So x should belong to 2, 3. And that is the interval in which the whole thing will be increasing. So this is the stepwise discussion of what I just told, and whenever you have log, you have to find out the domain by yourself so that you know that how it's going to be finally working. If the function fx equals to 2x square minus kx plus 5 is increasing in 1, 2, then k lies in which interval? It is increasing. Okay, so clearly it is being shown that it is increasing. So what we'll do, we know already that we will just take the differentiation f dash x. This is going to be 4x minus k. It is greater than 0 because it is increasing. That means 4x should be greater than k. Or you can say k is less than 4x. Alright. Now x is between 1 and 2. I am saying x, it is given in the question already that x should be between 1 and 2. When you multiply 4, just multiply inside 4, 4 and 8. So x belongs to 1, 2, 4x belongs to 4, 8. So k should belong to where? K should be less than whatever amount 4x gives us. 4x is giving us 4 and 8. So that is the interval which becomes 4 and 8 from 1 and 2 when we multiply 4 with x. So k should be less than 4 because the lowest value of this 4x is 4, highest value is 8. So it has to be less than 4x, which is less than 4. Now what is the interval? It's negative infinity to 4 because till what point you will go? On the left of 4, it is negative infinity. So k belongs to negative infinity to 4. So this is the whole process or the steps which you can follow in order to solve it. Let fx is this one. Be an increasing function on set R, then a and b should satisfy or must satisfy. Okay. When we are not in position in beginning that how are we going to go about it? The only thing which we can do is to differentiate. Let us differentiate this first. F dash x is, this is x cube. It's going to be 3x square. I'm just differentiating normal differentiation. Ax square is 2ax. Bx is b only. So we have this as plus 5. Sin square x is 2 sin x. Then differentiation of sin x is going to be cos x. So we have this 2 sin x cos x can be written as sin 2x. What do we get? 3x square. This is plus. So why did I write negative? It's a slight mistake. I'm making it plus. Plus 2x. Plus b. Now this is going to be plus 5 sin 2x. This is sin 2x. I'll just write it as sin 2x. It has to be greater than 0. What does it mean? Can you sense that this expression is nothing but a quadratic equation? This is a quadratic equation. Ax square plus bx plus c is the standard of a quadratic equation. So the determinant should be less than 0. What is determinant? B square minus 4ac. That is the discriminant. B square minus 4ac should be less than 0. From here we can get the condition for a and b. A is 3 here, b is 2a here, and c is total b plus 5 sin 2x. It is not sin x, it is sin 2x. I have written it, you can just change it. So ax square plus bx plus c. So we have b square minus 4ac. This is 2a whole square minus 4 into a is 3, and then c is b plus 5 sin x, sin 2x. So I've just changed it as sin 2x. It should be less than 0. So 4a square minus 4 is 12, and just multiply inside for 12b, and minus 5 into 12 is 60 sin 2x. This should be less than 0. Okay, now let us divide everything by 4 so that you get a proper equation which resembles the solution. You get a square minus 3b minus this is 15 sin 2x. This should be less than 0. Now coming to the sin 2x. This sin 2x, because what we got is a square minus 3b minus 15 sin 2x. So all those first and second and third term also we got as similar to the options which are being provided here. Sine 2x or sine theta should be less than and greater than certain value, which is -1 and 1. So let us take the minimum value. When we take the minimum value, then only we are going to satisfy this less than 0 term. So in sine 2x, we are going to put -1. I will not put +1. Please remember. -1 because it is the lowest value and we have to check for less than 0. That is why we have taken the -1. So a square minus 3b plus 15, that is the proper solution of this question. Now the whole procedure which you are going to follow to solve it is in front of you. This question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.